This is Precalculus Pre-AP. This is the handout on 1.4, 1.3, and I had reserved one question for the end of the day that I wasn't able to actually finish. This is example 4. This is after my first period notes. So first period I was able to set up the problem, but we didn't get any further than this because the time was up. So we have the setup. So it says a piece of property has the shape of a right triangle, so we drew what I call a right triangle. The longer leg is 10 meters shorter than twice the length of the shorter leg. The hypotenuse is 20 meters longer than the length of the longer leg, which I think I set this up improperly. Yeah, so this is not set up properly. So 20 meters longer than the length of the longer leg. So if I call A the shorter leg, or I called it X actually, and I'm using A, B, and C to apply the Pythagorean theorem. So if the shorter leg is called X, so it's some value X that I don't know, then the longer leg is 10 meters shorter than twice the length of that shorter leg. So that's 2x minus 10. But then the hypotenuse, it says that it's 20 meters longer than the length of the longer leg. So I put x plus 20, but that's 20 meters longer than the length of the shorter leg. So that c is equal to 20 plus the length of the longer leg, which is 2x minus 10, which I could simplify. 2x plus 10, I believe. So you would drop parentheses, 2x, and then 20 minus 10 is positive 10. So then this one, c is the one that's going to get replaced with 2x plus 10. That's going to get squared. So there's my setup. A squared plus b squared is equal to c squared. So what we need to do is we need to simplify and then solve for x. And this is a quadratic equation, most likely. X squared plus 2x minus 10 squared. That's a perfect square. We can apply the formula, 4x squared. There's going to be a minus in between because there's a minus in between those two. You multiply 2 and 10, which is 20. Multiply that by 2, 40x. And then you would square the negative 10, which is plus 100. Likewise, the one on the outside, 4x squared plus 40x plus 100. They're almost identical except for the sign in the middle. 2x minus 10, 2x plus 10. So here I have a big expression on both sides, and then we combine like terms if I am able to. So let's see, on the left-hand side I can combine or one thing I could do is probably just cancel those out before I start combining stuff. So normally what your algebra teachers would have taught you is to combine all like terms on each side of the equation first, and then move stuff. You can move stuff first and then combine like terms as you see fit. So I'm going to move stuff. The 100s also cancel. They match, so if you would subtract 4x squared on both sides, both of those would cancel. If you subtract 100 on both sides, both of those 100s would cancel. So then I get to move maybe this 40x. I want to move everything to one side. That's going to be a minus 40x, and you get x squared minus 80x equals to 0 if I do this properly. And now I have to solve. So there's one of many ways I can solve this. If factoring is possible, that's the way you want to go about it. So I think we could factor. There's a common factor of x. So because there's a common factor of x, we can factor out the x, set this equal to 0, and now the 0 factor property is applicable. So you would set each individual factor equal to 0, x equals to 0, or x equals to 80 if you solved for x minus 80 is equal to 0. So we get two possible solutions, x is 0 or x is 80. So which of these is actually true? Can x equal to 0? So this is a geometrical problem with a practical geometrical solution, hopefully. 0 would not be practical. So if I plug in x equals to 0, immediately the shorter leg is going to equal to 0. We can't have a right triangle with a short leg equal to 0, or measuring with a distance of nothing, or a side length of nothing. So that's going to get thrown out. So it has to be 80. And that's meters, because the problem was designed so that way these lengths were in meters. So the units is meters. So that's going to be 80. Then we go ahead and find out what the rest of the lengths are. So 2x minus 10. So that's 10 shorter, so 10 meters shorter than twice the length of the shorter. So you take twice the shorter, which is 160, minus 10, and you get 150. So that's 10 meters shorter than twice the length of the shorter leg. Same idea here. You take twice the length of the longer leg. Oh no, you take the length of the longer leg and you add 20 to it because the hypotenuse is 20 meters longer than the length of the longer leg. So 20 plus that. So really just plugging in 80 if you want. 160 plus 10 is 170. So really it's just 150 plus 20 because they said 20 added to the longer. And these are in meters. So this is what they wanted, the lengths of all those sides. So the lengths of the sides of the triangular lot, which means all three sides. And that's all they're going to want for this particular problem, and that's all that I had left for this section. So that's going to be the end of 1.4, 1.5.